For the next section, we're going to start talking about carbohydrates. So another thing you might better know in carbohydrates is as sugars. So these are simpler carbohydrates, and these go all the way from things like table sugar, which is sucrose, to even simple sugars, sugars such as glucose or fructose, and then even more complex polymeric chains of these simple sugars known as polysaccharides, which we know as, for instance, starch is a very common polysaccharide. And so these collectively are useful in a number of physiological processes such as structural molecules, such as cellulose, which is a polysaccharide, which is important for cell walls and for plants, or complex carbohydrates can also be used in energy storage, such as for alpha amylose starches, once again, and glycogen. There we go. And so we're going to start by introducing some nomenclature. So we're going to draw a very simple sugar. Here on the board, and this is called glyceraldehyde. Okay. Glyceraldehyde. Okay, and so simple sugars typically come in one of two flavors. So, and we think of this, we classify these based on where the carboxyl group is. So if the carboxyl is at the end of the sugar, this is actually an aldehyde group, right? Okay, so this is known as an aldose. All right, and so we further classify this by the number of carbons there are. So for D-glyceraldehyde, there are 3 carbons, 1, 2, 3. And so we call this, more specifically, an aldotriose, or tri indicates the number of carbons within the sugar. Okay? And so if there are 4, it'll be an aldotetrose, and then if there are 6, we can have an aldohexose, and so on and so forth. Okay. The counterpart to this is a ketose sugar. So we'll draw one here. Okay. The carboxyl group is in this position. Okay, and this is known as a ketose. The specific name for this is D-erythrulose, and this has 1, 2, 3, 4 carbons, and so we can further categorize this as a ketotetrose. All right. So, aldose has an aldehyde group. A ketose has a ketone group. All right, and that's how we can classify. These are 2 major classifications of simple sugars. Right? So as we go further into this, we're going to look at several things. One is the stereochemistry of sugar. So first, I'll note that these are both written in their linear conformations. So they're linear and cyclic conformations. So these are the linear, and we'll talk more about the cyclic in a later video. Okay, And when we draw in a linear form, we also draw our stereocenters as a Fisher projection. Okay, so for D-glyceraldehyde, we have one stereocenter, shown here. And then over here, we also have only one stereocenter, because this is an sp2 carbon, so that doesn't have the stereocenter. This has two hydrogens, so that's not a stereocenter. And this also has two hydrogens, so that's not a stereocenter. So when we look at this, when we look at naming, so D indicates the stereochemistry using the DL naming system